In the large-scale experiment, we actually planted a real forest with pollard willows, and we made real-life waves that we have in a once in every 10,000 year storm here in the Netherlands, very huge storm with high river waters. And for that we tested whether these trees were strong enough and actually were damping the wave height. In the project we are looking at the use of forests, woody vegetation on floodplains and how this can help to increase flood safety of the dikes in the Netherlands. So we did large-scale experiments before in the Delta flume, the largest wave flume of the world, and with real trees. But of course that is very expensive and very cumbersome to perform. So we would like to be able to do the same kind of test at small scale. But they are not completely resembling reality. We have scale effects, the strength of the trees, the flexibility of the trees, the actual wave damping, they are all not represented completely right. So to take into account how much these effects are, that's why we also have to perform the same tests at a smaller scale. Until now, there have been a lot of small-scale tests on mangrove trees and other trees and wave damping, and actually we are still doubting how valid are these tests. So now we have done the large-scale tests here, and if we replicate precisely the large-scale tests in a flume like this behind me in a small scale, then we know we have a quantification of the scale effects. So suddenly we can use all the small-scale tests that have been done before and see how valid these results actually are. So probably we will mimic the trees with an artificial material like 3D printed plastic or something like that. So the large-scale tests have been done a time ago, but now we at the TU Delft are starting with a grant from MWO, the Research Council, with a PhD student that will study these wave damping properties. And she will analyze more in depth the large-scale tests, she will perform the small-scale tests, and from that we will make all kinds of formulas and computer models that we can use to predict the wave damping properties of forests.